All right, so section 10.2 that we just finished, and then this section 10.3, which we're starting, really are just one giant section that your book has split into two, okay? So this is just a continuation of what we were doing last time. We're going to discuss some more ways of displaying data. And the first one we're going to look at is line graphs. You guys see line graphs a lot. So let me describe what they are, and then I want you to think about where you might have seen these kinds of graphs. These are line segments connecting one data point to the next, typically showing the trend of something over time. Okay, so we're looking at things that have sharp line segments, not sort of a smooth, curvy thing going on. Can you think of anywhere you've seen line graphs?
History.
Sales sometimes?
History classes usually for
On
any kind of trends.
any kind of trends in a history class?
Like a child's growth and like their weight.
Sometimes you will see it on a growth chart for a child's height, weight. You can do measurements of other things like that too with children in education systems, something like grades, changing their grades or how they test over time. Another one that I know you've seen is you've seen stuff with stock market, haven't you? They're crazy. They go up and down like nuts. Those are all line graphs. So they typically show the change of something over time. So we're going to take a look at this one. This one says, a learning specialist tracked the average reported studying times of her students. Create a line graph for the data that she tracked. So this is all data within the course of a week, okay, that she's collected. Hang on. Okay, so this is like the last ones. We're going to create a chart or a table or a graph, whatever the situation is. It's going to need a title. It's going to need labels and all that good stuff, okay? And as we take a look at this, we're going to draw, in this case, a vertical and a horizontal axes. What's going to go where? Because there's a natural way to do this. The days are going to go on bottom. So as we're looking at line graphs, nearly always you see the time as a measurement along the horizontal axis on the bottom. So we're going to mark each one of these, and we're going to mark out the day of the week. And I'm going to label them. I'm just going to label them with the letter, the first letter. With the exceptions of the ones that repeat. There. So here's my days of the week, and I'm going to label that bottom axis what? Days of the week. I am. I really am. Yeah, you bet. And then my vertical axis is going to be measured in terms of what? Hours. Yeah, it's going to be hours, and I'm going to start at 0 because that makes sense. What's actually the smallest value in this chart? Yeah, that's that Saturday time, right? And Friday for that matter. Both of those are 0.25s. And the largest value is 2. So my chart's going to start at 0 all along the horizontal axis, and it's going to go up in measurements of what? 0.25s would be good, right? Because I actually have a 0.25, and all of these are actually measured within a 0.25 level of accuracy. In other words, I don't have a 0.37 number of hours. Okay, so they're measuring it in quarters of hours. Okay, so just like last time, we're looking for at least a visual evenness. I know it's not perfect, but that's kind of what we're shooting for. If you have lines on your paper when you're working on your homework, that'll be great. Help you to keep that. If you want to use actual graph paper to do some of these, you can do that too if you happen to have any, or if you want to print some from online, because you can get digital graph paper from online too. And so I'm going to mark every other one of these. So this is 0.5, 1, 1.5, 2, and my axis is going to be labeled as what? Study time in hours. I'm going to do a label for my graph, and I'll do it, I guess I'll just do it at the top here. I've kind of left myself not a lot of space. But what is this chart going to measure when I'm all said and done? What is my table going to be for, this graph going to be for? The study times what? Oh,
students
that's
done.
good. Let's put average in there. I like that. Average study time for students in a week or throughout a week or something like that. And you can put that label at the bottom of yours if you've got more space there. I just don't have space to put it. I normally put my labels on the bottom, but I don't have it here. Okay, we're going to make a point for each one of these data points. So the first one from Monday should be at 1.5. So we studied 1.5 hours on Monday night. On Tuesday night, 1.75 hours, so a little bit more. On Wednesday night, 0.75, we were at church. Yeah? Maybe. Thursday night, 2 hours. I think we probably had a test on Friday. And then Friday night and Saturday night, I'm speculating that that's actually probably high. I'm thinking it would probably be closer to 0. Would you guess? Just thought. But we'll put it in there according to what it says. So it says I'm supposed to have 0.25 on Friday and 0.25 on Saturday. And then Sunday, of course, it goes back up because school starts the next day and we got to catch up on everything we didn't do over the weekend that we were supposed to.
On the Wednesday time, you said 1.2.
The Wednesday time, what was that?
You put it on.
Oh, I put it in the wrong spot on Wednesday. Thank you. I'll fix that. Thanks, Heather. Okay. More or less in the right spots now? Thanks. All right, and then we connect these with straight lines. This is like connect the dots, right? Like back when you were a kid, 1 to 2 to 3 to 4 and the thing at Chili's or whatever the kids do. You know what I'm talking about? So we're going to connect these with straight lines. And that is a line graph. That's all it is. Okay, any question? Okay, let's go to the next one. The next one is actually called a scatter plot. A scatter plot is often used to show a relationship when variables cannot be easily depicted even by a broken line, like we just drew, because that was a line graph. It's kind of broken lines, line pieces. Now, I'm not claiming that this data could not be expressed in that way, but that's when you usually see scatter plots used, okay? We're going to draw a scatter plot for this data, whether or not you believe that it is necessary or not, okay? So Coach Lewis kept track of the basketball team's jumping records for a 7-year period as follows. We're going to draw a scatter plot for the data. And then we're going to talk about the association. So if I forget, remind me I needed to talk about the association for the data once we're done, okay? All right, so all a scatter plot does is it does what we did on this last problem, but it doesn't put the lines between anything. That's it. That's all a scatter plot is it's just the dots on the graph, okay? So on this one, we notice we have years along the top. We've got the record inches along the second line. And we're going to draw an XY axis for this. Which piece is going where? The years is on bottom. And we did something last time when we had years on bottom or something on the bottom where it doesn't start at year 0. Do you remember what we did? We did that little break, and we're going to do that again here too. So back over here. Draw yourself a little break in the data. And it's not going to break very well, but something like that where you're indicating that there's a spot in there that you're not reporting everything. We're going to start this in the year 2000 because that's the first piece of information we have data on anyway. So we'll start with 2000, and we need to go up to 06. Okay, so I just labeled every other one. And then along this horizontal or this vertical axis, what am I going to have to do? I need a break there too. Why?
Because it starts at 65.
Yeah, and I don't really want to have the information beneath that on there. I mean, could I?
Yeah.
I could, but it's really not pertinent to what we're talking about, right? It would make the graph look kind of odd to have all that dead space at the bottom that's not part of what I'm really concerning myself with. So I'm going to take this same piece here. That wasn't what I wanted to do. And I'm going to make sure that I get that piece cut as well. And it's not working for me. Let's do this. All right, so we've got this cut as well. So I'm actually going to start with the smallest value. I think you guys already told me it was 65. And then the largest value is 77. All right, so I'm going to start down here at 65. You ran out of space like I did. I didn't make mine tall enough. There you go, right in the middle of the words. I'm at 77. We're just going to go with it. All right, so we can label every other one or every third one or something like that. I'm starting at 65, 68. I'm going to label every third. 71, 74, and 77, which puts me right at the top, so that's fine. And we're going to label the axes. We haven't done that yet. Let's go ahead and do that now. So what do you have for me? Good. Years for the x-axis. What else? So record what? Jumping record would be good. So, you know, we can put jumping record here. I'm going to just put record because I'll put jumping in the title of the graph. But here's the record. Yes, I need the inches to be labeled here. This is the record in inches. Let's go ahead and do our dots, and then we'll put the label on the whole thing, and I'll put it out to the side. So I'm supposed to do 2000 as 65. 2001 and 2002 are both at 67. 2003 is at 68. 04 is at 70. 05 is at 74. And apparently somebody joined the team that jumps really high, because we're at 77 now. Those last two pieces are a pretty big jump. So could we connect all the dots? We could, but the problem just asked us to do a scatter plot, and so we're done with that piece of it. Now we do need a label, so what's this graph going to be labeled as? We can use that part. We probably don't have to have it, but this would be the jumping record. Instead of saying throughout a 7-year period, how about we say something like jumping record from 2000 to 2007, because that'll get that information and be a little bit more specific about the years at the same time. Something like that. So this is our jumping record. Okay, any question on that? Because one thing I told you to tell me.
Until 2006.
Oh, it was only to 2006. Sorry about that. Okay, let's fix that. 2006. I told you to not let me forget to do something. What?
Association.
The association. Okay, what kind of association is this? Okay, so an association has to do with what's going on over time. So if over time it's going uphill, that's a positive association, and if over time it were going downhill, that would be a negative association. So this one is a positive association. So this is a positive association. Now, the next problem actually tells us to graph a trend line. So you've seen trend lines probably used before as well. A trend line is a line that fits the data and can be used to describe it. Sometimes it's called a best fit line. If you're working within the context of regression. This is called a linear regression line. Sometimes it'll be taught in like an algebra 2 or intermediate algebra, college algebra type class with regression. And there's several ways to find it. We're not going to be finding the best fit line exactly. We're going to be approximating. So take some straight edge that you have in front of you. Maybe it's the edge of your calculator. Maybe it's the edge of another sheet of paper. You can grab your ID card or something out. Just find something that's got a straight edge to it, okay? You need that straight edge to be able to be put on top of the paper you're working on. Okay, so take something out of somewhere to be able to place it on top. We're going to go back to the last problem, and we're going to draw the trend line in on top of that graph. That's what we're going to do. So we already did the scatter plot. I'm about to do a trend line for my scatter plot. Okay. So taking a look back at this slide, what you're really going to do, maybe I can do it with my binder, is you're going to take that straight edge that you have and you're going to try and put it in here so that it hits and crosses through as close as it can to all the dots. Okay? So some of the dots you're going to cross to closer than others, but you don't want to make it so much that you cross through a whole bunch of them exactly and one of them is just way out in the middle of nowhere for your line. Okay? So your goal is to get to it as close as possible to as many of them as possible. Is everybody making sense of that? Okay? So you're going to draw a line in here, and we're not all going to have the same line, and that's okay. So I'm going to sketch through what looks like to me, and you're going to sketch through what looks like to you, and we're all going to be happy that none of them match. They should all still be fairly close, though. Okay? It's pretty good, right? I mean, it gets pretty close to it. Does yours look pretty close to that? Okay, so tell me some of the things that you notice. This is a line, obviously. What do you notice about this line? The slope is positive. That goes along with this idea of a positive association. Right, what does slope mean? Can you remind us? Rise over run. We kind of talk about how steep something is as being its slope. And then what else do you notice? Generally speaking, it doesn't hit all your points. Most of the time it won't. Somewhere down here it's got a y-intercept too, doesn't it? But it's really hard to tell because we actually did this sort of break in my graph. It's not negative. It looks negative on this graph because it's crossing that x-axis, but it really isn't negative, right? Because we clipped this graph apart and we only are showing the top piece of the graph anyway. So there's several ways that we can do this to find a trend line. If this actually crossed the axes, we could just see the y-intercept, agreed? But we've got this break thing going on, and so that's unhelpful at best. Another thing we could do is we could sort of look like what we were doing to count down. So looking at the way that I've drawn the scale, this actually looks like it's almost like from the measurement of the y-axis here over to the year 2000, looks about twice as big, doesn't it, as my other pieces right now? So this distance right here looks about twice as big as the actual lengths that I did across the y-axis, or the x-axis, doesn't it? So it almost looks like that if I were to sort of put a mark in between there, that'd be the year 1999, and if I came back to here, that'd be the year 1998, and so forth. So you can think about it that way. You could also think about moving your axes, and that's actually what I want to do, because that's the easiest fix to get our graphs equation. So let me show you. I'm going to take, we'll see how much of this will really work. I'm dragging it. I promise I'll move some stuff back. How about that? So the year 2000 is actually now on top of this. I understand my break in my graph didn't quite move right, but just pretend with me for the moment. So this is the year of 2000 now is my x and my y-axis, okay? Where does it look like it crosses now? About 64 maybe? Does that seem reasonable? I mean, I know it's not exactly right because I've actually got the point at 65, because that's what this up here said. It's supposed to be the 65. but along the line, the purple line, it's crossing it maybe around 64. Okay? What about slope? How do you estimate slope? Do you remember how to find slope for a line? So, rise over run. And rise is your y values, change in the y values, right? And run is your change in your x values. In a very concrete way, what do you do?
Two lines on, or 2 points on the line, figure out what the price is.
And I really like, Lauren, that you said on the line, because that's really important. We need to pick 2 points, and the 2 points we have to pick have to be on the line. Now, if you happen to have your line going through one of your points, you could pick that. So like we could pick this one right here.
It's also going through the 77.
It's going through which one? Mine's not. Mine's not, but yours might be. And if it is, you could use that one, yes. So we're going to pick 2 points on the line. I'm going to use the one that I circled because it's on my line. And I'm going to say that this one's pretty close, and I'm just going to use it, okay? I mean, we're pretty close to that one. We're just going to pretend. So pick 2 points in your line, doesn't matter which 2 points. And we're going to find this line. So it says using the data in example 2, create a line of best fit. We already did part A. Part B says estimate. Keyword is estimate. Yes, this is important. Estimate an equation of the trend line. So the equation is going to say y equals. We need to find the slope. And then we know that the y-intercept we said was about 64 on my graph. Right? So we need to find the slope. So slope is found by taking y values on top, corresponding x values subtracted on bottom. So I'm going to do my second y value over here first. What was this value? 74? Right there? Okay. So this is 74. And the x value that it corresponded to is the year 2005, wasn't it? Yeah. I'm running out of space there. Let me do this. The other point that I circled was here in the year 2002, and it's at 70 or 67. All right, so what's 74 minus 67? It's 7. And 2005 minus 2002? 3. If this simplified, we would simplify it, but 7 over 3 doesn't. If you want to express it as a decimal, you can. This is an estimate, so you're allowed. So if you want to write this as approximately 2.13, let's just say 2.3. Yeah, 2.3 repeating. You could use that. So an estimate for your graph is the equation y equals 2.3x plus 64. And yours may not match that, and I'm okay with that. There's one thing you have to do, though. You have to describe how you're measuring the distance x. This distance x right here matters. Because if I put in x equals 0, I'm going to get the value 64, which represents my y-axis, right? But what year is my y-axis represented by right now? Yeah, it's the year 2000, isn't it? So if I put in x equals 0, I mean I'm talking about the year 2000. Are you guys with me? So what I have to do down here is I have to talk about what x is measuring. This actually gives me a number of inches, which is important. But this is the part that's perhaps even more so, where x is the years after 2000. What x is measuring is how far away I am from the y-axis. Well, if the y-axis is the year 2000, I'm measuring how far I am away from the year 2000. So if I wanted to predict, for instance, what's the high jumping record or whatever, long jumping record, I don't even remember what I was doing. But what's the jumping record in the year 2010? You do not want to put 2010 into this equation. What do I want to put in? 10. And that's what this piece of information actually tells us. So we're going to do that. We're going to do it for this year. So this year is the year 2013. So what input am I going to put in? 13. So we're going to plug in the number 13 for x. Again, because we're measuring after the year 2000, because the year 2000 is represented by my y-axis. All right, so somebody's got a calculator. You can put it in yours as well. Would somebody put it in mine so that it'll match what this one is? 93 point what? 9 inches, right? Wow. Okay. So trend lines you have to be careful with, right? If you go out too far into the future, it may not predict very well. But if you do something close out, like if we had predicted the year 2007, we probably would have been fairly comfortable with the answer that we got. So the closer you are to the data range you're talking about, the better the trend line is at predicting in general. All right, last piece on this one. We talked about briefly, Brendan actually mentioned it, that what kind of line is this? This had what kind of slope you mentioned? A positive slope, and we talked about that being equivalent to the idea of being a positive association, right? Is it going uphill? Well, you can talk about that with a line without even data associated with it. So we have 3 different lines here, and the question asked is what kind of association is represented by each trend line below? So what am I really looking at? What's in front of the x, which we call the slope. I'm really concerned about the slope. The slope gives me the information here. So on the first one, I actually have a slope of -2. What kind of association is it? It's negative. How about the next one? Positive. That's a positive 4. You can hardly tell now since I've circled things, but it's a positive association. What in the world happened on the last one? The slope is 0. Well, why can't I see that then? I don't see a slope. It's understood. Could I write it like this? Yeah, I could, right? It would be the same thing, and then you can actually see the 0. This has, well, it has 0 slope. In terms of associations, this is a 0 slope. Don't use the word no, because that means something different. This is a 0 slope, so the association is that there is none. There is no association. So none, or you can say no association. Not no slope. It has a slope. Its slope is 0, but there is no association. Okay. Any questions on that? All right.